Today our class is about dielectrics. The outcome of this dielectrics is applications in engineering materials. We study in these topics as first one is properties. We study about non-polar and polar materials. Later we learn about what is meant by permittivity and the susceptibility. We learn about polarizations, electronic, ionic, orientation and space charge polarizations. And we study in this dielectrics Lorentz field, another name Lorentz internal field. We can call it as local field. Later classes Masodi equations. This depends upon the internal field. Properties of dielectrics. Dielectrics are insulators. Next, die means two, electrics means charges. Here we study two types of materials, non-polar materials and polar materials. So in non-polar materials, positive and negative charge coincide, there is no charge. Next, polar materials, separation of constant materials. Insulators, electrons are bounded, so there are no free charges. This dielectric materials comes under non-metals. They have very high specific resistance. They withstand at high voltage. And we use these dielectric materials to store the charge inside the capacitors. Dielectric properties. Applied electric field. They are of two types, DC and AC field. If you place the material in DC electric field, material will be get polarized. In AC field, material will lose the dielectric nature. Later dipole momentum, that is mu, polarizability, alpha. Later we learn about permittivity, three types, medium permittivity, vacuum permittivity and relative permittivity. Later dielectric displacement, this is also known as flux density. Later two types of forces, Lorentz force and Coulombic forces. We study about equilibrium between Lorentz force and Coulombic forces in our lesson. Both of them will be get balanced. Later another how much the material will be get polarized is expressed as the susceptibility relations. Later electric dipole momentum mu. Here is a dipole symbol. In this dipole symbol we see positive charge and negative charge with formula mu is equal to QR, and we see various dipole natures. In some of the figures there is no net dipole, but there exist some dipoles in some of these natures. Examples H2O molecules. This is said to be the dipole figure, and the product of the charge and distance between the two charges is known as electric dipole, which we express the symbol mu is equal to QR. Here we see the dipole plus positive charge and negative charge at certain distance r, and this is electric dipole momentum. So the product of charge and distance between the two charges is known as electric dipole momentum. So this is represented as the Debye meters. Here we see several dipole momentum pictures. Some of them are polar molecules and some of them are said to be the non-polar molecules. Here we represent the figure in which positive charge and negative charge there exist force lines. Force lines are said to be the flux lines. The arrow mark represents E, that is electric field direction. So the first formula is D proportional to E, that implies D is equal to epsilon E. So here the material is in the medium. If we consider the material in the vacuum, then D is equal to epsilon naught E plus P. Here we get additional polarizability. If we consider the relation between epsilon R and Xi, that is epsilon R minus 1 is equal to Xi, or epsilon R is equal to 1 plus Xi. Xi is said to be electric susceptibility. This indicates how much the material is polarized. Here we see two figures, that is no electric field and applied electric field. If there is no electric field, dipoles are arranged in the random, and if electric field is applied, then dipoles are arranged in the regular order. And electric susceptibility is the ratio of the polarizability with applied electric field. It has no units. That implies if Xi is equal to P by E means P is equal to Xi, or Xi is equal to epsilon R minus 1. So the present topic is about various polarizations. So when the specimen is placed on the DC electric field, specimen means the considered material which is to be polarized. So if the material is placed on the DC electric field, then material will be get polarized. The material is placed in the AC electric field, then material will undergo the electric loss. There are four types of polarizations: electronic polarization, ionic polarization, orientation polarization, and space charge polarization. We consider electronic polarization in atoms, and we consider ionic polarization in ions, and later we consider orientation polarization in the molecules. Let us study one by one. First one is electronic polarization. When EF means applied electric field, it is applied to the atom. Then atom has two types of constants: positively charged nucleus